All right. Does this make it too dark? Can you all see to write on your notes?
Yeah.
And this is honor.
Yes.
Nope. You know my rules. Okay, so it was no joke that we did transformations in the first unit, where we talked about translation. What is a translation? It's a slide. If I'm doing a horizontal translation, which way would I slide? Horizontally, which means which direction? Left and right. All right. Left and right, my friends. So we're going to do horizontal translation. So I picked this to do after we completed the square because you need to be able to get your equation into vertex form first. So that's what we did when we completed the square. Okay. So whenever you complete the square, whatever value is inside the parentheses with your x, think about it. Which way does the x-axis go?
Left and right.
Left and right. So it makes sense that the number that's with your x moves your graph left and right. Okay. The biggest thing, and that everybody struggles with, when h is positive. Okay. So when h is positive, that's actually x minus h. Okay. When I have x minus h, that means I end up with a positive h. Okay, remember, it was always opposite when we factored, and we ended up with x minus h. That meant my h value was positive. Okay. So if I have x minus h, I have a positive h, which means in turn, if I have x plus h, my h value is negative. So if I have x minus, it's going to shift to the right. It shifts opposite of what you would think because your h value is actually positive. And when we have x plus, it's going to move to the left because, again, your h value is actually negative. Okay. Everybody good with that? Okay. So let's open up this flap. Whoop. I'm going to use some colors here. If you have highlighters or colored pencils or something, you may want to do that as well. Give me some colors that you can actually see. All right. So number one up there, this is what we call your parent function. Okay. It's your original function, and then it produces children. So this is your parent function. Okay. It's your original. It's where every quadratic starts before we start transforming it. Okay. So your parent function has a point at the vertex. Your parent function has a point at the vertex. From the vertex, you have a point that's to the right and up one. And remember, at the vertex, we have a line of reflection. So that means I have a point to the left and up one. So here's your parent function. Okay. So if I change your parent function to be the quantity of x minus 3 squared, x minus 3. So what's my h value? If I have x minus 3. It's positive. So my h value is actually a positive 3. So if my h value is positive, which way is my graph moving? to the right by 3. Okay, to the right by 3. So each one of your points now is going to shift to the right by 3. So this one goes 1, 2, 3. This one goes 1, 2, 3. And this one goes 1, 2, 3. By the time this is said and done, what I want you to get out of this is the fact that I can give you any type of equation in vertex form, and you can tell me how it should move. Okay? You should be able to look at any equation I give you and tell me it goes to the right by 3, down by 2, and it flips over the x-axis. Okay? Take a look at number 3 then. What is my h value in this one?
-2.
-2. So which way am I moving?
Left.
To the left. Okay. The biggest thing is remembering if it's inside the parentheses with the x, it should always be opposite. So again, from the original picture, we're moving to the left by 2. So 1, 2, 2, and 2. Okay. Try the last one on your own. And then
Why
we'll
do
talk
we
about
use
it.
the other picture? Why do we use the other picture?
Because it's transforming from the original picture. Everything will transform from the original picture. Which way did my graph move in number 4? To the right. Good. My h value should have been 1, and we moved to the right by 1. So that's here, here, and here. That's a fun looking picture. All kinds of crazy. So again, inside with the x, it moves it along the x-axis. So it moves it left to right. And again, always opposite. Okay. All right. So we have a horizontal translation, which is left and right. On the other side, we have a vertical translation, which is going to be up and down. Up and down. Okay. Your vertical translation comes from your k value, which is the number that's added out to the side. Yeah. Go. Oh, picture day. Oh, my Kevin. Yes, we're on the top right flat. Okay, so vertical translation. Notice the number that changes and moves me up and down is not with the x. So if it's not with the x, it affects your y. Okay? The beautiful thing about k, though, is no matter what it is, that's how it moves. So if it's plus k, it's going to move up. If it's plus k, it moves up. When k is negative, it moves down. Okay? So the x's are always opposite. The y's are not. They move in the same direction that you see written. Okay? That's where everybody seems to get it all mixed up. It's not that you don't know how to do it. You don't remember that. Okay? So if we open up this flap, Again, we start with that original equation. So x squared. So you have a vertex at the origin, 1 point to the left and 1 point to the right. Okay. Okay. In number 2, I've got x squared and then plus 1. Okay. So we're moving, Allison said, up 1. My k value is 1. So that means I move up by 1. So each point moves up by 1. So plus 1 moves it up by 1. Number 3 is x squared minus 2. Down by 2. Good. Down by 2. So here and here. Take a second and do the last one. Take a second and do the last one. There's a big bottle over there. Brandon, if my last one is x squared minus 4, how is my graph moving? Down by 4. Fantastic. My k value is negative 4. So that means I move down by 4. So this graph should be down here. Question. We good with horizontal and vertical translations? Okay. Your graph does 2 other things. We're going to start on the left-hand side. A reflection. Reflection was your what?
Flip.
Your flip. Okay. Reflection is your flip. So remember we had that upward facing parabola or the downward facing parabola. Okay. We've kind of already talked about this one. So when my A value is positive, whether it's in front of x squared in standard form or whether it's in front of the quantity of x minus h squared in vertex form, if it is a positive A, it opens up. And if it's a negative A, it opens down. Okay. So if your leading term is a positive, it's a happy face. And if it's a negative, it's a sad face. Yes.
It's gonna be on the bench.
Yes. Absolutely. Okay. Happy face, sad face. So let's open this one up. Ooh, not only did I put happy and sad face in here, we've got some shifts going on too. So we're adding everything all together. Oh yeah. Okay, so number 1, x squared. What's my A value? Positive 1. A equals 1, which means I open up. That means I open up. So that's why your parent function looks like this. Okay, it opens up. Okay, take a look at number 2. What's happening? Got negative x squared. My a value is a -1, which means what?
Opening down.
We're sad. We're opening down.
Are we in art class or what?
Yes, absolutely. Math is an art. Okay, so all that did was make your happy face turn sad. Okay, the next one. Okay, remember, we're doing reflection. So what's my a value in number 3? +1. It's not written there, so it's a +1. So a equals 1, which means opens up. Okay, but I've got x plus 1 quantity squared. So what else happens to my picture? It's a horizontal translation. Which way are we going? Horizontal. Left one. To the left, to the left, to the left. Don't make me hit the wall. Like y'all tried to make me do before. No. Okay. So this means your h value is actually a -1. So we go to the left by 1. So all that's happening is I'm moving to the left by 1, and it goes upwards. So it looks like this.
Does the next one go to the right by 1?
Huh?
Does the bottom one go to the right by 1?
Mm-mm. Still goes to the left. What's the difference between number 3 and number 4? It opens down. So it still shifts to the left by 1. You still have that x plus 1. So my h value is still -1. So it goes to the left by 1. But Justin said this time my a value became a negative. So now it opens down. So vertex is still here, but this time we've got a sad face. That one actually looks like DNA.
Yeah, it does.
We're bringing science into math class too. Or a chromosome. Is it a chromosome? Something like that. Chromosome? All right.
Oh, no. Wait.
I knew I was talking something right. Somewhere. Yes.
Can I take a picture of like the ones that I missed?
Let me finish this and yeah.
Okay.
Okay.
Oh, do you want this one back?
I
It does look like DNA. It does look like DNA.
Oh, no, that's what's in there.
and this has nothing.
I had to be the one plus one.
It's the K value. So okay. All right. Last one. Last transformation. Okay. Do you remember me telling you about your graphs that get really, really fat and wide and the ones that get really, really skinny? Okay, your A value does that as well. Okay, so these are dilations. Okay, if I dilated by a number that was a 2, bless you, what happened to my picture?
It's a straight mark.
Okay, it got bigger. Okay, you would multiply everything by 2. That kind of happens here, except it's more of a slope per se. Okay, so if my A value is greater than 1, the graph is stretched vertically. Okay, that means it gets taller. Your graph gets taller. Okay,
I hate it.
we call this skinny norm. Okay, it takes your normal function and it makes it skinny.
Hello.
Hello.
I know you have a full one, but you're about to have one more.
I don't have calculators for this.
kid.
Oh, you killed me.
I thought it was 10. I was like, what is wrong with 13 feet?
Right. I'm about to say that's why
As long as we can get you a calculator, we're good. All right. Okay. How many of you have world history next period?
Me? Which
Oh,
class?
look. Miss Walker.
Me.
Look, you've got some friends. All right. We need to find my friend here a seat.
Here, freshman.
Where do we have a seat open?
Here, right there.
That's Kevin's seat.
That's you.
Over there.
All right. So we've got either a seat in front of my friend Mo here, or we've got a seat in between Daniel and my friend Quentin here. He's gonna sit over here with the boys.
There you go.
We got you. We got you.
Now we're talking.
She's full just as much as I am.
We got a class of 11 kids.
Yep. Gotta love it. We make it happen. We make it work. As always, we make it work. Okay? Yes. Guys, this is our new friend Makai. Okay?
I thought we should stop class.
As soon as I finish these notes, Makai will let you know.
Yeah, we gotta stop
All right.
class. I wanna be here.
Jeremiah said we gotta stop class.
Yeah, we gotta get
All right.
to know people.
Let me finish these notes,
No.
and then we can get to know Makai. Okay. All right. So when your A value is a number that is bigger than 1, we get taller and we've got skinny norm. Okay. When my A value is less than 1, okay, it doesn't mean that it's negative per se, but less than 1. So, so 1/2, 1/4. What's the what?
What's that say?
It says taller, skinny norm.
Oh, taller, skinny, normal.
Yes. Your graph gets taller, and we call it skinny norm. Because if I take you and I stretch you by 2, like this, what's happening?
I'm getting taller.
You're getting taller. You're gonna get skinnier.
I want to be taller.
Okay. Focus. Focus. I know we all had a whack today between pictures and
People.
we got this.
No.
Okay. So when you have an A value between 0 and 1, this is fatter.
I'm so sorry.
And
I
fatter,
only had a babysitter for so long.
You're fine.
Now they're gonna glue that in.
Uh-huh.
fatter is shorter.
And y'all do one every day.
No, not necessarily every day.
Fatter.
Just with new
Fatter.
lessons.
Just with new lessons, and then they have their notebook that they can go back.
Fatter.
Yeah. So like we did the one
Such a
real
great
root,
teacher.
no real root,
You
two
teach
real
us
roots.
so much.
You're fine.
Make us
Thank you.
make learning so easy.
Say bye, Mr.
Fatter and fat with fatter and fat.
Okay. So.
Why you say shorter?
Okay, shorter. Okay. All right. All right. So, fat norm. Okay. If I take you and I cut your height in half and I squish you down, your weight's gonna go like this, and you're gonna get fatter.
Well, let's squish
Okay.
Justin.
Not quite as fat as Miss Smith, but
That's what I ate.
Let's squish Justin down this bit. For real.
That boy just don't get like.
all right. So.
What is that?
Let's take a look at this. All right. So this first graph, this is regular norm. Okay, this is regular norm. So again, point at the vertex. It goes to the right by 1. And because this is a reflection, it also goes to the left and up by 1. Okay, so that's regular norm.
That seemed pretty regular to me.
It seems pretty regular to you? What's my A value in number 2? It's a 2. Okay, so we're going to kind of use this as a slope. This is 2 over what? 1. So that means up
2 over 1.
and to the right 1. So watch what happens. I still have a vertex at the origin. It didn't move. We didn't move left and right. But now instead of my first point going up 1 to the right 1, it's going to go up by 2 and to the right by 1.
So why that
Okay.
point don't move?
Because there's nothing that's subtracted with your x, and there's nothing that's added or subtracted with your y. Okay. So in order for it to be a vertical translation, to move up, you would have had to have something added or subtracted to the end. In order to be a left or right shift, it has to be added or subtracted to your x. We have nothing added or subtracted, so it's not shifting. Okay. Again, because this is a reflection. Give me 1 second, Mo, and I'll answer your question. Okay, because this is a reflection. If I have one that goes up 2 and to the right, I also have one that goes up 2 and to the left. So it got skinnier. Okay, your graph got skinnier. It's getting taller. Okay, yes.
Why didn't the vertex okay, so why didn't we go from the vertex like we did with the last? Like we went from the vertex and then we went from the other point and went up to. Why didn't we go up to from the other point? From the other point instead of we went up to the vertex.
So we just go from the. So we go from the vertex.
Everything goes from the vertex when you're dealing with dilation. Everything goes from the vertex. Okay. Yes.
I still don't understand.
Okay. First off, you all are being very rude because I have people asking questions and I can't even hear what they're saying because you've decided to have conversation over top of it. Enough. If it has nothing to do with math, I don't want to hear about it. What was your question now, please?
I still don't understand that. How did you move up 2 and move to the right 1? I don't see that.
From here, I went 1, 2, and to the right. Okay. So let me make up a different one. Okay. Let's do 4x squared. Okay. 4x squared. So what is my a value with 4x squared? 4. Goes up 4 and to the right 1. Okay, so this always starts from the vertex. My vertex is still at 0, 0. Because again, there's nothing added or subtracted to your x, which would move it left or right. And there's nothing added or subtracted to the outside, which would move it up and down. So that tells me we start at the vertex. So now my first point goes up 4 and to the right 1.
So are we graphing this?
Okay, yeah, we can graph this too. Okay, again, what happens on the right-hand side also happens on the left. So look how skinny that one got. As my a value gets bigger, my graph gets skinnier and skinnier and skinnier. Until what?
Disappears. That would be fatter.
Okay, so number 3, my a value is what? 1/2. So that means it's getting fatter. What's my slope look like with a then? 1 would move it up, 2 would move it
To the side.
to the side. Okay, so again, there's nothing added or subtracted to the x and nothing added or subtracted to the side of it. So we move up 1 and to the right by 2. Again, what happens on this side also happens on the left. So that's also over here.
That one's fat.
And there's fat norm. Okay, yes.
What's this Eddie Murphy game?
Okay, again, rude. Please stop talking. I cannot hear when you're talking. What's your question?
What did you say when you know that it starts with the vertex?
Starts with the vertex because there's nothing added or subtracted to your x in parentheses, and there's nothing added or subtracted to the right. Okay, so anything added and subtracted is what moves it left, right, or up, down. Okay, so because there's no addition or subtraction, that tells me I start at the vertex. Yes, Brandon? No, absolutely not. Remember, with your quadratic, you've got that axis of symmetry that goes through your vertex, which cuts it into 2 equal halves. So yeah, it can never be out of sync. Okay, so let me make up one here. Let's do 1/5 x squared. What's my a value? What's my a value? 1/5. And how do I move? 1 up into the right by 5. So now I go up 1 and 1, 2, 3, 4, 5. And again, what happens on the right happens on the left. Woo! That's like super fat Norm. It's a beast. Okay. Okay. Question. Problem. All right, guys, this clue's in on page 66. All right, 66, friends.